Determine if each set of vectors are coplanar. Okay, what does the word coplanar mean? It means that all three vectors exist on the same plane. If you want to visualize this, think about having three pencils and you try to put them all on the surface of your desk. If all three pencils are laid out sitting on the surface of your desk, then they all exist on the same surface. They all exist on the same plane. That's kind of what we're talking about here. In fact, you can look at this 3D representation of three vectors and you can see how those three vectors all exist in the same plane. Whereas you can look at these three vectors and you can see that there's no plane that exists that all three of the vectors will be able to rest on. So let's look at this question. We'll start with part A. We're given three vectors and we have to figure out, can they exist on the same plane? Do they all exist on the same plane? How do we do this? Well, we can use our cross product and dot product to help us out. And this is actually what we call the scalar triple product, or STP. The plan is going to be that if we take the cross product of two vectors, we know that the cross product of two vectors will give us a vector perpendicular to each of those vectors, or perpendicular to the plane that those vectors are on. So the surface that those two vectors exist on, that third vector will be perpendicular to that plane. Now, why is that useful? Because if there's another vector, a third vector, let's say this vector here, that also exists on this plane, then it will be perpendicular with that vector we found by doing the cross product. So if we take the cross product of two vectors, say these first two, and we get this vector as an answer, and then we determine that that new vector is perpendicular to this third vector, this one down here, then that means those original three vectors all exist in that same plane, and therefore they're coplanar. How do we figure out if those two vectors, the one we found with the cross product and the third vector, this one, how do we figure out if those are perpendicular? Well, we can take the dot product between them, and if the dot product is equal to 0, then we know they're perpendicular, because remember the dot product formula that says that the dot product of two vectors is equal to their magnitudes multiplied by cos of the angle theta. The angle between them, in this case, would be 90 degrees. Cos of 90 is 0, so you expect if they're perpendicular that when you take the dot product, you get an answer of 0. So enough explanation, let's get into the actual question. Like I said, we'll start by taking the cross product of those first two. If you cross product those first two vectors, you'll have I, J, K, 1, 2, 3, 5, 7, 9. Okay, we set this up. And if you're not sure how to do the cross product, check out the cross product video, okay? So we put our 2, 3, 7, 9, our 1, 3, 5, 9, and our 1, 2, 5, 7. 2 times 9 is 18. 18 minus 3 times 7 is 21. 18 minus 21 is negative 3, so we have negative 3i, minus 1 times 9 is 9. 3 times 5 is 15. 9 minus 15 is negative 6, but it's minus negative 6, so it will be plus 6. Over here we have 1 times 7 is 7. 2 times 5 is 10. 7 minus 10 is negative 3, so negative 3k. All right. In other words, this vector could be written as negative 3, 6, negative 3, if you just want to write it in component form like that. So remember I said those two vectors, we take the cross product, we get a new vector. That new vector is this one here. Now we have to see, is that vector, the new one, perpendicular to a third vector, this vector? Because if it's also perpendicular to that one, remember it's perpendicular to this one and this one already. If it's perpendicular to all three, then all three exist in that same plane. They all exist on the same surface. So let's take the dot product. We'll take the dot product of that third vector and the vector we just found. So 8 times negative 3 plus 10 times 6 plus 12 times negative 3. 10 times 6 is 60. 8 times negative 3 is negative 24. 12 times negative 3 is negative 36. Negative 24 and negative 36 make negative 60. So 60 and negative 60, that makes 0. So because we got an answer of 0, that means that this vector we found, this vector here, is perpendicular to this third vector. And that vector we found is also perpendicular to these two vectors, the first two. It has to be because it's the result of the cross product, which means that all three of these vectors up here, 1, 2, 3, must exist on the same plane, which means they are coplanar. So the answer to this is yes for part A. All three of these vectors exist in the same plane, and you can take a look at this 3D representation of what these vectors look like, and you can see that, yes, in fact, they can all be shown to exist on a single surface. Let's try part B. We'll do the exact same thing, and it doesn't matter which two you start with. In this first case, I took the first two vectors to do the cross product. It doesn't matter which ones you pick. For this one, how about I pick the first one and the last one, and I do the cross product with those. I, J, K. We'll do 105, 631. Okay. We set this up. Put our numbers in. So 0, 5, 3, 1, 1, 5, 6, 1, 1, 0, 6, 3. I don't know why I drew this one so far off to the left. It should just be in the middle like this, but that doesn't matter. We're okay. Now let's do the math here. 0 times 1 is 0. 5 times 3 is 15, so 0 minus 15 will be negative 15i. 1 times 1 is 1. 5 times 6 is 30. 1 minus 30 is negative 29, but it's minus negative 29, so it'll be plus 29j. And then over here we have 1 times 3 is 3. 0 times 6 is 0. 3 minus 0 is 3, so 3k. In other words, we have the vector negative 15, 29, 3. Now, we have to do the dot product between this and the remaining vector, the vector we did not use in the cross product, so I'm going to pick that middle one. Let's do the dot product. Negative 15 times 11 plus 29 times 4 plus 3 times 2. If you go through this work, you should get as an answer negative 46. That is not 0, which means that these three vectors do not exist in the same plane. They are not coplanar, okay? Not coplanar. So we took that cross product between two vectors, got another vector like this, which is perpendicular to both of those. We have this third vector here. We said, is it perpendicular to this vector as well? No, it's not. Maybe it looks something like this. So it's not perpendicular to it. It has a different angle. So that means it's not on the same surface as these other two. If you'd like to visualize this a little bit more clearly, take a look at this 3D representation. You can see here clearly that no, those three vectors do not exist on the same plane. There's no way to make a flat surface that all three of those vectors are lying on directly. Hopefully, this makes sense.